In this stained slide specimen, the contents contained in the protoplasm appear as granules. In this case, the blood of a cancerous patient was vaccinated in vitro with a Legionella culture. Although the white cell has engulfed some foreign particles and parasites, its resistance has reached its capacity and bursts, thereby releasing its contents still alive. This experiment shows isolated living cancer cells from a bladder tumor in a nutrient fluid that has been vaccinated with thrombocytes. The purpose of this experiment is to determine if thrombocytes are capable of destroying cancer cells. The latest plague on humanity is the AIDS virus that, until now, has not been observed in the living form. The new microscope has enabled us to make the following observations. In this culture trial, we have discovered 3 different sizes of the same virus. The growth of the virus is, amongst other factors, characterized by jumps made by the size B viruses. The AIDS viral particles in the vital blood transform white light into a deep red color, which indicates that its optical resonance frequency is to be found chiefly on this wavelength. Vital blood slides show how a thin layer of leukocytes are segmented by the AIDS virus. This tissue structure, consisting of multiple overlapping layers, is shown with the conventional phase contrast technique at maximum magnification. You can only see a few contrast differences without any details. The Ergonome 500 microscope shows, using a substantially higher magnification and resolution, more details of the interlacing tissue layers, with both more image depth and depth of field. Another section of the same sample shows the tumor cell, as shown here on the top right, which divides itself in 30 minutes. This process can be precisely followed through the use of time-lapse photography. The same situation as found on a different part of the same tissue structure. In comparison, if you use a conventional bright field microscope, such fine details cannot be seen. Another tissue sample in normal bright field illumination only allows you to observe faint tissue structures. With the Ergonome 500 microscope, using grey field illumination, all the structures can be seen clearly with good image depth right up into the foreground. This connective tissue culture was filmed using the phase contrast method. The Ergonome technique, using a higher magnification, allows the cell cores and granulation to be clearly recognized. This living culture can hardly be assessed with normal bright field illumination. The Ergonome grey field technique allows you to clearly resolve all the structures with increased contrast and a convincing image depth. Tissue samples from other parts of the body prove the unique high-quality images that can be obtained with the help of this new microscope technique. This example shows the Ergonome technique, normal bright field, and the Ergonome technique again. This tissue, shown in phase contrast technique, has been infiltrated with a tumor. Using the Ergonome 500, it becomes possible to enlarge the center of the picture to show the explosive effects of the malignant growth tendency. In the left half of the picture, you can see a tumour attached to the liver cell in the process of division. This dividing tumour cell, on the above left of the picture, is currently being attacked by killer cells. On the above right of this picture, you can see a solitary tumour cell, about 25 micrometers in diameter, that is in a nutrient solution. Here, some dividing tumour cells are being attacked by killer cells. In a further trial, where cancer cells in a solution were destroyed electrolytically, the following phenomenon could be observed using the ergonome 500. Gas bubbles appeared with thick-walled membranes. During this process, so-called oriented ion channels become visible in the membranes. On the points of contact, rotary biaxial polarized electric fields appear. In this Legionella culture, this phenomenon can be demonstrated in the border zone between the air bubble and the bloating cultivation. With the ergonome 500, you can observe material that has been stained, as is always required by conventional optical microscopes. Despite this undesirable staining, it is possible to see even more details with the new microscope. Such staining is, however, not required for observations under the ergonome 500 microscope. The ergonome 500 allows you to use both bright field and grey field methods, which allows you to obtain a better image quality and more information. Through the ability to use an even higher magnification and resolution, a more detailed interpretation is possible than ever before. The purpose of this short scientific film was to compare the results obtainable with conventional microscopes with the newly developed and improved ergonome 500 universal microscope. These comparisons illustrate some of its many commercial advantages, especially in the disciplines of medicine, biology, pharmacology, chemistry, polymers, electronics, metallurgy, as well as interdisciplinary research. For more details and examples of real-life microscopy with the ergonome 500, please visit our website at www.grayfieldoptical.com.